Okay, so this is example 3 that we had started yesterday in class and didn't actually finish, or Friday in class and didn't actually finish. So here's my ladder. I have all the forces marked in. So there's the Fg of the ground, or the F friction of the ground, F normal of the ground, F normal of the house, the weight of the ladder, and the weight of the person. Okay? And so we can start with some of the forces. So if we do some of the forces in the x direction, it's not moving in the x direction. And so in the x, the only two forces we have are F normal of the house and friction of the ground. And they're going in opposite directions, so F normal of the house will be equal to F of friction of the ground. And we had that in class on Friday. Then we could do some of the forces in the y direction. I think in class I did them opposite. And in the y direction, the forces are the F normal of the ground going up, the weight of the ladder going down, and the weight of the person going down. Always in the y direction. We are trying to get an expression for normal. So we'll take the weight of the ladder, which is really m of the ladder, g, and the weight of the person, which is really m of the person, g, over to the other side. And we have numbers here, so we can actually find this if you want. So the ladder is 10 kilograms times 9.81 meters per second squared. And the person is 60 kilograms times 9.81 meters per second squared. And so that's really 70 kilograms times 9.81 meters per second squared. And so 70 times is going to be 686.7? 686.7 kilograms. No, make that a Newton. Okay, now the question wants mu, and we know friction, and in this case it's friction of the ground, is equal to mu Fn. In this case, if friction's on the ground, Fn has to be of the ground. So we just found our Fn, and now we're going to find, we need to find our friction of the ground. But friction of the ground is equal to the normal of the house. So if we can find one, we can find the other. So we're going to do some of the torques, and we're going to pick our pivot point down here, so that we, in theory, would have 5 torques. Torque of the normal of the ground, torque of friction of the ground, torque of normal of the house, torque of the weight of the ladder, and torque of the weight of the person. I say in theory because if we pick our pivot point down here, these two will go to 0. We lie our writing utensil along the ladder. The F normal of the house makes it want to rotate counterclockwise. So that will be positive. The ladder and the weight of the person will make it want to rotate clockwise, so that will be negative. So we have R normal of the house. My thing keeps wanting to go to sleep. F normal of the house, sine theta normal of the house, minus R of the ladder, Fg of the ladder, sine theta of the ladder, minus R of the person, Fg of the person, sine theta of the person equals 0. This time, none of the thetas are going to be 90. Okay, so because they're all in connection to this 60 somehow. We're solving for F normal of the house, so take these two terms over and they'll become positive. R of the ladder, M of the ladder, G, sine theta of the ladder, plus R of the person, M of the person, G, sine theta of the person. We want to be left over here with F normal of the house, and that's not a weight. That's how much force the house is pushing back. It has nothing to do with how much a house weighs. So it's not an Fg. We're going to divide by R normal of the house and sine theta normal of the house. So now all we have to do is fill our numbers in. We'll figure out what they are, perhaps, and fill them in. So R of the ladder, it's a 10 kilogram, 5 meter long uniform ladder. So if it's uniform and 5 meters long, then Fg of the ladder is halfway along its length, 2.5 meters. Mass of the ladder, 10 kilograms. The angle for the ladder. The angle is always between the R and the F. So it's going to be this guy right here. And if that's 60 and this is 90, it has to be 30 degrees. So sine of 30 plus R of the person, 3/4 of the way up, a 5-meter long ladder. So that's going to be 3.75 meters. Mass of the person is 60 kilograms. Oops, I lost my 9.81 in here. 9.81 meters per second squared goes in here and in here. And then the angle for the person, again, between the R of the person, which is here, and the F of the person, which is here. So this angle will also be 30 degrees. So sine of 30 degrees. Then we are going to divide by R normal of the house. Well, the F normal of the house is up here, and the pivot point is down here, so the R is the full length of the ladder. So that was 5 meters. And the angle between, here's the R, this whole thing, here's the F. So the angle is this guy. Alternate interior angles tells us that has to be 60 degrees. So now, all that's left in this step is, can you type this into your calculator correctly? So sine of 30 is 0.5. 0.5 times 10 is 5. 5 times 2.5 should be 12.5. 5 times 2.5. And then multiply by 9.81. And I think I put my decimal in the wrong spot. I don't actually have my calculator, so I'm trying to do it on my phone. And man, it's not being nice, because it's not putting the decimal in for me. Times 0.5. No, all right, I give up. So you're going to get this number, whatever it is that I can't tell you right now because my phone doesn't want to work and my calculator's too far away. That's F normal of the house, but that's also F friction on the ground. And so once you have that, then you can go back here and you can say, okay, mu is equal then to F friction on the ground, which I just found, divided by F normal of the ground, which we had right here. So the number that I cannot manage to type into my phone goes on the top, and the 686.7 newtons goes on the bottom, and you will get your mu. Okay? So sorry that I can't tell you what that is, because the video will run out of time by then, but that's how you do it. Okay? So hopefully that makes sense, and hopefully you can now do the questions on the sheet and in the textbook that I assigned. All right, thanks. See you tomorrow.